Hello guys, my voice is audible to you? Am I audible?
Yes, sir.
So what we'll start doing today is like let me begin with the assignment first. Okay. So
Yes.
anyone who has started the assignment?
Yes.
Yes, sir.
So let's discuss the doubt first. So from 1 to 10, any doubt?
Yeah.
In the multiple choice question, only one choice is correct type. 1 to 10,
No, not from 1 to 10.
10 to 20,
Yes,
10.
sir.
Okay, tell me which one.
Sir, question number 12.
12. Okay, yeah, fine.
Sir, 13.
13. Okay. Okay. 13 today we are going to discuss anyway. That's our present today topic is 13, question number 13 only. So anyway. Yeah, question number 12, it's very interesting. I mean, this is something which I should have explained even a bit more. For any conductor, if you come near the surface, and if it is carrying some current, let's say, so the field must be like this because the field and the current will be in the same direction, right?
Yes.
So there are two types of electric field which actually exist. Every current and wire will have some charge, although very small, but it will have some charge, and the charge will create a normal electric field. This is E perpendicular, and this is E parallel. And basically, the J relation which we wrote in the last lecture, sigma into E, is basically corresponding to sigma into E parallel. Okay. So it is not the resultant field; it is only the parallel field which is used for the current density calculation. And we do have some charge over the surface, and that charge will have its own field. So the actual direction of or the resultant electric field direction will be something like this. So I think B option is the correct option in this case.
Yes. Yes. Okay.
13 I will discuss today, don't worry. 14, 15, 16,
No.
17, 18, 19. So these are very basic just for practice. I mean, it's not at all difficult. Tell me guys, any doubt in up to 20? Up to 30, from 20 to 30, tell me.
Sir, 30.
30. If cut a wire into two equal parts for a given voltage applied to its initial power loss, okay, the power part you can leave because I
Okay.
haven't
Okay.
discussed, so that's okay. Heat and power, I said, okay, you can leave that part. So that's a small topic, but it needs some discussion. 31 to 35. That's it. 31
So
is the
more than correct. I have doubt in the third question.
third question. So in the third question, length will increase, so the resistance will, what is the resistance?
The cube.
So R1 is along the x-axis, right?
Yes. Yes.
So you have to write rho into L by A, right?
Yes.
So A is, I think, small. A is same for all now, because for x-axis A is it's the cube, right?
Huh.
So you can call A square.
Yes.
So rho L by A, which is A square. That is for x-axis. Let's call Rx. For Ry, what we can write? Rho into. So for y-axis, the area becomes 2A square, right? But rho L becomes A, and
A
area becomes 2A
double.
square.
Yes.
And for Z, I think it's pretty much similar. RZ is rho by, yeah, it's also same. So the Ry equals to Rz. So 2 equals to 3, right?
Yes.
And 1 is bigger than all, right?
Yes.
So 1 is more than 2
ACD.
and 2 is equals to 3. So check out the answers.
Option A, C, and D.
Okay. Other question?
Yes.
Fifth question is done. Which of the following are non-ohmic?
Yes, sir.
So I think
B,
B,
C,
Yes,
C,
sir.
D.
D.
B, C, D. Yeah.
Yeah, that's logical. Because these kind of questions are not in like every book, so that's why I need to give. Otherwise, SRM is really good, and it would have been sufficient. 6, 7, 8.
No.
Okay. So theoretically, you understood the concept, right? So now you know
Yes.
like why this theory was required, right? So you are able to answer this question. It means you theoretically you are very strong now. So fine, the part is done. Okay, you could have done the passage number 2, the free electron model of conduction. Passage to anyone up, I
Yes,
mean,
sir.
tried
Done.
solving. So you got the answer.
Yes. But so first question I didn't get in that what uh
So the relaxation time of the order is so
order.
order means like the power of 10.
Yes. So
So we
in
know
rel
it's inversely proportional to root 10. Na?
yes.
So find the concentration and substitute here.
Okay, yes. Okay.
That should give you the answer.
Yes.
I think it should be 10 power minus 14. D should be the answer. Anyway, you can check.
Okay. Second, third, message.
What is the answer? I mean, this is the typical value, which I remember.
It's
Okay.
D only. Answer.
So then Ohm's law and resistance. The passage 3. Anyone who did the passage 3? No. And then there are many questions for practice. These are very easy questions. Like I expect that okay, you all can finish as fast as possible. So try to finish this week only. I mean, that's just the first part. The second part will be heavier than this in terms of calculation. Okay. So let me continue the discussion. So those who have solved more than 20 questions, raise your hand. The first 20. I would like to see how many you solved. Okay, but only 2. So rest will do after Diwali. You must be busy with some painting of your indoor and cleaning exercise. Yeah, seems like so all are busy. Or maybe the good muhurt will come after today. I mean, maybe the Shara, once the Ravan will get killed again, theoretically. Okay, so I'll talk about something called joint conductor. So imagine if you have 2 conductors in series combination. So we have two conductors which are joined. And what I'm doing is I'm keeping the cross-sectional area same for both. Okay. And this is the boundary, the interface you can see. Now every metal is made of different materials. So as you change the material, you change the density, you change the molar mass, and definitely what you change is the concentration. The N will be different. But as you change the concentration, you inherently change the sigma, okay, the conductivity, or you change the resistivity. You can say the way you want. So we say that every material, let's say one is aluminum, other is copper. So we have sigma 1, we have sigma 2. Okay. Now, what is the property of steady state behavior of any conductor? In steady state, what remains same? The current flow cannot change. Yeah, so that must
Yes.
be same. So current will be I here. And even if you cross the conductor and you go on the other side, you will get the same answer. Okay. And the way I have constructed this diagram, you can see the cross-sectional area is also constant. So if I say A as the cross-sectional area, we can clearly say that current density is also going to be a constant quantity, right? So by definition, the J is defined as I by A.
Yes.
And because I is constant, the A is constant, can we say that J must be constant? Yes or no?
Yes.
So even the current density is going to be constant throughout, but sigma 1, sigma 2, we know there is a relationship. J is sigma into. But if J is constant, that is only possible when sigma 1 E1 equals to,
Sigma 2.
which means clearly because J, this is constant. So the product of sigma and E must be same, which means the E must be different. So the first medium will have electric field E1 and the second will have electric field E. Understood? Do you realize this?
Yes.
Now, how this sudden jump of field value or change of field value will take place? While crossing the boundary, you will come to a region with different electric field. So who will change this field? Can you think about it? So what factor will change the field here? Because the field which we believe is created by the charge due to the battery, right? So the battery will create a plus layer here, technically, and a minus layer here. And this will create a potential difference. But now the field is changing its value again across the interface. So the obvious logical question is that who will change? Who is the agent of change? So what will be your answer?
So permittivity of the metals, like they're different.
The
But the
metals
question
are
is,
different.
yeah,
That
that is, metals are different. That's why we are saying sigma is different. But how it will change? What is the process of change? Like who creates the field? As I believe that it is the charge which creates the field, right?
Yes, sir.
yes.
So the question is how? So who will change the field? Even if you remember the dielectric, who was changing the field in dielectric? Do you realize this? No. Or yes, maybe. Tell me if you have realized. Who changed the field in dielectric? Any guess? Okay. It was the induced charge at the
Charge
interface.
distribution.
Yeah, it was the induced charge on
Yes.
the interface of air and dielectric, right? And
Yes.
that induction actually made the all difference in the field value. Similarly, whenever there is a change of medium, the interface, if you see electric field on one side as E1, other side as E2, The only thing which can change or make this possible is the induced charge at the interface. So some charge will get induced. Now, whether this charge will be positive or negative, I have no clue. I have no clue. But you can guess. Let's get a clue. So plus charge or minus charge, we can guess. How? If I know sigma 1 and sigma 2. So compared to aluminum and copper, which one is more conductive? I mean, the conductivity of which metal is more? Aluminum or copper? Anyone? Okay, no one.
I think copper.
Copper.
Copper. Yeah, many of you to use Google and tell me the answer. Anyone, please tell me. Yeah, it's copper is the winner.
Copper is more conductive.
Yeah, roughly double. Eh?
Yes.
Not roughly double, but yeah, it's almost. So copper is having more conductivity. Okay, so if sigma is more, to maintain the current density, the E must be small. Yes or no? E must be small.
Yes.
What do you believe? Yes or no? So E2 will be less than E1, isn't it?
Yes.
And that's logical from here now. If sigma 1 is more than sigma 2, then definitely the E1 will be less than E2. Am I right?
Yeah.
Okay, I hope this is clear.
Yes.
So now you want, let's say if in this case, okay, what you choose? You're saying sigma 1 is, okay, let me change it to the upper, discussion. So here the sigma 1 is less than sigma 2.
Less.
So E1 will be more than E2. So because E1 is more than E2, so you want the net field to be same, right? You want net field to be same. So what will happen? This interface will create, and you want to decrease the resultant. So there is only one field. There is only one field. The battery will create only one field. Let me tell you what. Battery will create only single field called E. Technically. And this interface has to increase the value of the field on the left and decrease on the right. So the interface will develop a negative charge. And what will happen? This negative layer will create a field which is like this. You can see. Because on the negative charge, it will terminate, isn't it? And due to this, what will happen? This negative charge will try to cancel the field on the right side, but it will add up on the right left side. Do you realize this? So if the interface is having sigma, so the field it will create is sigma by epsilon naught. This is the field of interface. So basically the actual field without any induction process and plus sigma by epsilon naught is actually E1 and E minus sigma by epsilon naught is actually E2. This is the reality. Understood? So the battery will create only this value E. So this E is the field due to cell alone. Assuming there is no induction in between happening, if cell is only responsible for the creating the field, then it would have created the uniform field throughout. But because of the change of conductivity, the field has to become non-uniform, and that will be accomplished using the interface charge. So interface will develop some charge, and this is always I have said that whenever there is a change of medium, we have an interface, and whenever there is an interface, we have some induced charge. And if you want to know the answer, it's very easy. You can subtract, and once you subtract, you get the answer. Very easy. So one So equation 1 minus 2 implies what we get? E1 minus E2, because E1 is bigger, no? Is 2 sigma by epsilon naught, right?
Yes.
So sigma we are getting is I think this is a mistake. I think this will be this is the non-connecting sheet with 2 times. That's a mistake actually. So for a single layer, we have always non-connecting behavior. So we have to write sigma by 2 epsilon naught, and therefore the answer will be only this much. So the answer turns out to be sigma equals to epsilon naught into E1 minus E2. So this is like how you can do it from scratch, but there is a better way of doing this. So the method 2 is using, so for every interface we have done in capacitor, so using cost. And if you have a Gauss law, if you draw an interface like this, and if you draw a cylindrical, let's say, surface, so the E1 is from this side and E2 is, always remember E1, E2 represents the resultant field in each medium. It is not the field of the cell. So the first method was just given to emphasize the fact that a battery will create its own field, but the field which you will get inside the medium is not the field of the battery itself, it is the resultant field. Okay. And in the Gauss law, we only use the resultant field. So Gauss law is only meant for the resultant field. So therefore, if you apply the Gauss law, what is the net flux? Sorry, E2 is on the right. This is again a mistake. So E2 is like this, my bad. So if you apply the Gauss law, what is the flux? Tell me. Assume the cross-sectional area is A. So can you see the net flux through this cylindrical surface?
Sigma by epsilon.
No, so in terms of E1, E2.
So
Acha, E1 into A.
E1 in minus of E1 into A
Yeah, minus of E1 into A and
plus E2 into A.
plus E2 into A. And this must be equal
Yes.
to charge enclosed
So what is it?
upon epsilon,
Upon epsilon naught.
which is same answer, right? It's one line answer. Oh, this is the surface. Okay, this is again confusing. This sigma is not the sigma of the connectivity. It's good to write the resistivity term so that we should not get confused with the surface charge density and the resistivity term. Okay. So maybe that is why like with the people felt the need of resistivity, because connectivity is very much confusing. It kind of collide with the symbol of surface charge density in the same context. So anyway, so that's fine. This is surface. This is surface charge density. Okay. So I hope this is clear. And
Yes.
you can easily guess if sigma will be positive or negative. It depends on E2 E1 value. So if E2 is more than E1, sigma is positive. If E2 is less than E1, it is negative. So this is pretty easy. You're not supposed to guess and get the answer. You just write the formula and then check what is given in the question. And because this condition is again very important. So whenever if we have multiple conductors and with different connectivity, even though the cross-section area you keep same, the field will change to maintain the J value. Okay. So now you can check the question number 13 and tell me, are you getting the answer, yes or no? Everyone solve question number 13.
Sir, got it. Option A.
Okay, option A is matching.
Yes, option A.
Right. So how many of you are getting the answer? Option A, please tell me, raise your hand. So anyone else getting the answer for 13? Only one answer. Huh? All right, very good, Archit. Anybody else getting the answer? Okay. Oh, good. So again, we have done this in capacitor as well. So what you need to remember is that whenever there is a change of medium and change of field, what you need to remember that some charge will induce on this interface, and that will affect the field on the left and the right. So the net field, the field which the battery or the cell will create is one value. Interface will create the other value, and interface will add and subtract with the field of the cell to create the resultant field, which is what we represent as E1. So E1, E2 is a resultant field. They may ask you another question. They may ask you, what is the field due to the cell? So if you subtract, what is the field due to cell? The answer is you can add the equation 1 and 2. So 1 plus 2
E1
implies
E2 by 2. E1 plus E2 by 2.
it is the arithmetic mean, right? The average.
Yes.
So that's very interesting answer. Like if you know the field of the two medium, and if they ask you find the E of the cell, and the answer is pretty much obvious. So every method, method 1 is also having its own advantages, and method 2 is of course having its advantages. It's good to know both. Okay. So I hope there is no doubt in this part, particular part. If you have any, raise your hand. Yes, I'll move to the next topic. So I believe that you are still processing the information, and will take some time to respond regarding you have doubt or not. But whenever it comes, do let me know. So we'll do something very simple, class 10 part. Effect of cutting and stretching a wire on its resistance. So when you cut a wire, do you change the resistivity? Yes or no?
No, sir.
When you cut a wire, do you change the cross-section area? Imagine the wire is thin, you're cutting just normally cut. Like. Okay, so let me draw the wire quickly. So if we have a simplicity here, the resistor circuit symbol is this, but if we don't have a resistor like this here, okay, this is just for the meant for the circuit representation. So I hope you all have seen the resistor.
Yes.
Anyone who has not seen the resistor? If not seen, please immediately search on Google and see the color coding. It's a really beautiful resistors are like cute piece of small piece, and it will have some color coding. You can also use for decoration purpose if you want, but if you don't want, It's okay. So if we have a conductor and A is the area of cross-section, L is the length. Resistivity is the medium property. So medium, of course, we don't change by cutting. So whether you cut or the way you cut it, really not going to affect the row part. The L and the A are geometry. So we have derived the formula resistance equals to rho into L by A
L by
for only for cylindrical conductors, right?
yes.
I hope you remember this.
Yes.
So if you cut into two pieces, keeping the area same, L1 and 2. So resistance of, so we can say if rho is constant, A is constant, so R will be proportional to L, and therefore the R1 by R2 will be in the
L1 by
ratio of length. That's pretty much simple. So one should know that. The measure is stretching. So if you stretch stretching of wire, let me write. So quickly, if you have a wire and if you stretch, so you will not only affect the length, but you will also affect the cross-sectional area, right?
Yeah.
yes.
So in ideal situation, the length will increase and the cross-sectional area will decrease, but we believe that the internal geometry of the metal is not changing, and hence the volume will remain same. Sometimes volume also gets affected, which you might be aware of from the elasticity chapter. Sometimes the stretching will totally change the geometrical orientation of atoms. So this generally happens with the cross-linking polymers, in which they change the shape. I mean, you can say the hybridization will change in a way which can entirely affect the volume also. So there are many objects which upon stretching increases the volume. There are many which decreases the volume. But in case of metal, we are going to assume that the volume is an entity which remains constant. Okay? So the simple rule that we are going to follow, that in the stretching process, volume remains constant. Again, I'm saying although it is not necessary. So this is merely an assumption, and by default we have to follow this assumption unless it is something explicitly mentioned in the program, that take the Poisson ratio into consideration and also check for the volume change. Then that will become the challenging problem. So if I say this is area of cross section as A and the length as L, so we can write as, I mean, this area is, let's say, A dash, length as L dash. So the first thing you can always write is the AL equals to, which is a constant quantity. So this is the first equation you can write. The second you can write is the R definition, which is rho into L by A. So now to understand the effect, you have to express the answer in terms of volume. So we can write as L by AL, so multiply and divide by L, or okay, anyway, so we rho L square by volume. So rho is constant, volume is constant. So this implies the R is proportional to L square. Now look at the difference. In cutting, R is proportional to L, but in stretching, R is proportional to L square. So when you stretch twice its initial length, the resistance becomes 4 times. That's pretty much obvious thing. Don't expect such kind of question in any examination. This is pretty, maybe it may be part of some intermediate calculation, but this won't be a full question. So this formula we can again write as rho AL by A square also. That's very interesting. So R equals to rho into volume upon A square, which means R can be inversely proportional to cross-sectional area square. But there is one more interesting part that because generally we consider the cross-section as circular. And if I say the radius is R, so R is inversely proportional to A square, but we know area itself is pi square, which means A itself is a square of the R, so we can say R is. So in terms of radius or diameter, we can add the relation as now for elementary change. So we know that R is, this is particularly of my interest, the first and this one. So dr by R. Now this is what you can learn always, that whenever you want to write a differential equation, you just write the fraction. So R will have fraction dr change upon original, and to write the fraction here, you have to write, the best way of writing is multiply the power and write dl by L. That's it. So power gets as a product or multiplied. If you want to derive from scratch, those who are not happy with this way of writing, for them you can write as R equals to some constant L square, then add dr by dl 2kl. Now to get rid of L, sorry, k, you can write dr equals to 2kl dl, and therefore dr by R is 2kl dl, and R is how much? Kl square. You can see clearly that this will be 2 dl by L. Now this is not required to do, so you just write the fraction and multiply with power, and that is a simple way of getting the differential relation whenever you have something like this. So similarly, can you tell me the answer will be, what will be the answer? dr by R will be how much? The fractional change in the capital R is equals to
-4
-4 times fractional change in
dl by
dr by r.
the radius, right? So let's say if you
Yes.
reduce, if the cross-sectional radius upon stretching decreases by, let's say, 0.25%, then how much resistance will increase? Answer is 1%. 4
Yes.
times, right? So for a
Yes.
small change, we can always use the formula. For large change, you have to go through the exact relationship. Okay, so these are something very basic. Now we'll do the. So I have done this a lot in Capsita, but I'll just repeat for 1 or 2 problem to give you the momentum so that you can also work on your own. So calculation of R for given geometric shape. So this is the question number, I think 10 or 11 of SC Verma. So that's the first term question you must have seen. So, but before that, I'll just give you a simple question. You can see there are 3 sides. Okay, let me name it quickly. A, B, C. So see, in case of formula R equals to rho into L by A, the A must be constant. But the question is how we decide the A. So we decide A in terms of flow of current. If I choose I1 as the current flow direction, the A will change and so the L. So every current path, the I, for every given I, the L and A will change accordingly. So what is R1? Tell me. R1 is basically the resistance for the first surface. I mean, if the current is going this way. So A will be the surface perpendicular to the I, right?
Yeah.
So what will the answer? This resistivity is rho. So R1 equals to rho into, what is L here? For the
C.
I1, the
C
L is C.
upon
Wait,
AB.
AB.
So R2 is how much? R2 means the I2 actually. So what is R2?
Rho A upon BC.
Rho A upon base. And R3?
Rho B upon AC.
Oh, I think R2.
Uh,
Yeah. It is rho B upon.
AC.
So is this clear for all of you? Like anyone having doubt in
Yes.
this?
Yeah.
So let's do it for other shape. So you can see we have a frustum, or you can say it's a tapered cylinder, and so the radius will vary from left end to the right end. Always remember that it is almost impossible to solve the question if the shape is really random, something like this. I mean, it is difficult to find the mathematical formula always. It really doesn't matter whether it is given in the question or not, but normally the A and B that we take are roughly same. So A is slightly on the lesser side than B, but they are not varying much. So you can imagine the difference as 1 millimeter. The right is 1 meter more than the left. That is possible, but geometrically it looks like a frustum. And why we do so? Because we want the current to be almost straight. Okay, so if you make a highly tapered, the current not be straight. It will like go. It will like the lines of force will flare up. And although we can calculate the answer mathematically, but when we try to re-evaluate using some experiment, we will see a large difference in the experimental value and the theoretical value. So the two values will be close to each other and will conform to each other only when this condition is met, that A and B are not varying from each other by large value. So the variation is minimal, you can say. Although you are not supposed to bother about all this thing. It's just being said for future reference. So we say length as L, and again, see, I will say length as L only when you understand. When L is length is L, then A and B are almost same. It's like close to center, right? Otherwise, the L is different, slant length is different. So we don't want that difference to really impact the calculation. The resistivity we keep as a rho. And now the moment you try to write formula rho L by A, you won't be able to write. Why? Because the formula is only true when this is only true when
Cylindrical conductor.
the cross-sectional area is constant. So the
Okay.
direction in which you move, the direction of flow of current will not. So here we are taking the current flow like this.
Yes.
So it should not see a variable area, but here as you go from left to right, what do you expect? The area to increase or decrease or remain same?
Increase.
Increase. So it means you cannot apply the formula. So what is the solution? If you don't apply, then what you do?
Elementary and
You take
integrate.
elementary, because when you take elementary, it's a thin cylinder, and thin cylinder will have the uniform cross section, isn't it?
Yes, sir.
See, that modus operandi is everywhere throughout physics. If you have realized it, it's really good. If not, please do realize. Elementary is not something which is forced upon us. It is the only choice that we are left with. So you can see I have cut a thin slice of frustum, And of course, when you cut, you have to be very careful about the mathematical way of cutting. Anything which you cut must be mathematically expressible. Otherwise, there is no meaning. So now, if I move x and if I cut dx as thickness, I'm not taking slant, I'm taking dx. And if I say the radius at this position as small r, can you guys tell me what is the dr value? Can we apply this formula for here? Dr.
Rho dx upon the area, which will be 2 pi r.
Area is 2 pi r.
L,
Are you sure?
2 pi r into L. Hello.
Yes. Okay. So much confusion, huh? The inventor of pi will suicide if he knows that area of a circle is 2 pi r. See, what do you mean by area? I mean, the whole idea of area is confusing to you. Area means what area the current will cross. So current is crossing which area? 2 pi r. How the current is flowing here? Along
Through
the
a circle.
axis. So what area you are crossing?
Through a circle, so pi r square.
Pi r square. So area will be rho dx by pi r square, right? Why you said 2 pi r? You thought current is coming this way.
I took the element. Yes.
But how the current is flowing? It is
Yes,
flowing.
yes, huh?
You realize your mistake?
Yes.
So the resistance is rho dx by pi r square. Can we integrate this now? Can we integrate this now?
Yes.
The answer is no. Why no?
We need to write r in terms of
X,
x.
or dx in terms of r, right?
Yes.
And you know how to do this. You have done this maybe in past.
Yes.
So tell me guys how you are going to relate x with r. Simple geometry you can find.
We will take that as
Do it and tell me. Not an
theta.
issue.
Okay.
Take your time. Receive, tell me the answer.
Sir.
Yeah.
Sir, I got the whole answer.
me the
Rho
answer.
L upon pi AB.
Very good. So what is the r value? Tell me. R is equals to how much?
I took it as like tan theta is equal to r by x and solved it.
R by x. Okay, what is r? What you wrote r?
I wrote it x tan theta, like I took the angle as
Which angle? See what is given to you, a and b, and you're just supposed to express r and x. So this is x, right? This is whole is L. So tan theta we can write as r minus a by x equals to b minus a by L. Understood?
Yeah.
So basically r is a plus b minus a L x. Or if you differentiate this equation itself, you get a dr equals to. There are two choices. Either you substitute r and solve, which is something which I will not prefer, or replace the dx, which is easy. And r will go for. So the answer is pretty much simple. It is rho L by pi ab. And there's a very famous trick for first term question. You can just take the think as a cylinder and they replace the radius by the geometrical mean of a and b. And then write the formula for the resistor, which is same as, isn't it?
Sir, can you repeat that?
Pardon?
Can you repeat the
Yeah.
cylinder? Yeah.
So the simple trick is you replace the entire first term by a cylinder and take the radius of cylinder as the geometric mean of a and b.
Yeah. Okay. Got it. Directly.
And then you can write the formula directly. Rho equals to r into rho into L by a, which is pi r square, and r is root a.
EP. Yeah. Got it.
That's a simple trick. Normally we use for solving the dimension question, but as a method you should know how to derive it. Is this clear?
Yes, sir.
Yes, sir.
Just one last question, then we'll move to the next concept actually. Anyway, so you can see something really interesting. So this angle is theta. So we have to assume that theta is tending to 0. It's a very small angle. Particularly, it's the thinnest slice of cheese which you cut. Okay. And what is given is that the inner radius is A and outer radius is B. This is A and this is B. And the thickness is given as T. So you are supposed to find the R1, R2, R3. Think about it, then of course I will solve. So take elementary carefully. Preserve the symmetry. You will get the right answer. So I think we had discussed something like this in capture also, right?
Yes.
Yeah. You should be able to do this. Once you do this, it means your elementary and everything is okay. So you can go to the next answer.
Hello.
Yeah.
Sir, is R1 rho ln of B by A upon theta T?
R1 is you're saying rho ln B by A upon theta T. Okay.
Yes.
Maybe. For one, for one, how you're going to take the element?
Sir, like in the between
The elementary for one will be something like this.
yes.
Because the answer first will be something like this, a bent curve.
Yes.
So current will move like this and will reach the other end. Like this. And therefore, because we are going to cut this, so we are going to cut this at some distance r. So the dr you can attach dr1 equals to rho. What is L here? Because the elementary is r distance away from the center. So L will be how much, guys? Tell me. How much?
R theta.
R theta. Very good. And what is the area of cross section? So you move r. This is the dr, right? This is dr. Area will be. So current is entering through what area?
dr into t.
TDR.
Area. Very good. And you can see such elementary. If you go from like innermost to the outermost, all elementary will be in parallel. Do you realize this? Because they have the same terminal.
Yeah.
So therefore, we can say 1 by r equivalent equals to. And anyway, logically, because dr is in the denominator, so we have to make it like this. So t is a constant and rho and theta is constant. So what the left with is dr by r from a to b. Therefore, the answer is E ln b by a upon rho theta. So R1 turns out to how much? Rho theta t ln. I hope this is clear to all of you. R1 is rho theta t ln. So can you do it for R2 now? The elementary is same. The only thing is, in case of I2, the current will go this way, right? Do you realize this? Same elementary,
Yes, sir.
but
Yes,
the
sir.
current is this way. So what is the L here? How much length you travel to cross it?
R theta.
L. I mean, you don't realize it. None of you are able to realize this. What is L? L means rho into L by M means L is the length of conductor along the flow of current.
Yeah,
Oh.
Along the flow. And area is perpendicular to flow. That's the whole idea. If you remember these two simple line, you will never get confused. So what is L here? What is area? Say what is the L? The length. Come on. I mean, if you move along the di2, what is the length you're crossing?
radius.
Not able to realize. Look at the diagram carefully. Try to understand. What is the L here? What is the L for elementary? L for elementary here. I mean to say, what is the L for elementary here? Anyone? In the formula of rho r equals to rho L by A, what is the meaning of rho L and A? Are you all able to understand this definition, L, A? So what do you mean by L? The length of conductor along the flow, right?
Yeah, length.
So what is L here? For elementary part, what is L? How to write L for elementary? What is the L? I mean, what happened? You are not able to understand L? Hmm. Yeah, of course I know its length. I'm asking L in the context. So for DI2, what is the L? L means this is the medium you're crossing it. What is L? How much you're crossing? See, we have to use the same formula, rho L by A. But what is L here? What is A here? So the L becomes dr, which you don't realize at all. So rho dr, which is L, and area is how much? What is the area? Tell me. How much area you're crossing? Okay, anyway, I think we will never get this answer. It is r theta into t. No idea what I wrote. So you're crossing this part, na? What is this area? R theta is the arc length. T is the thickness, which is the area of rectangle. T r d theta, right?
Theta ln b by upon rho ln b by upon theta t.
Okay, here dr itself is in the numerator, which means
Yes.
all such elementary will be in series or parallel. Which combination you see? Okay, you don't know in series combination. In series combination, resistance will add up, right?
Yes.
See, when I say I2, it means this is the positive terminal and the far end is the negative terminal. That is for I2. Similarly, when I say I1, this is the positive terminal and this is negative. When I say I3, then this is the positive terminal and below one is the negative. So you have to think in that way, that how to solve question based on what are your terminals. Okay. So rho into L by A is a generic formula for uniform cross section, but what L represents? It is the length in which current is flowing. So why you are not able to understand what is L in the context of elementary? So in this context, how much di2 will flow, and how difficult is to see this? Tell me. Why none of you are able to see the dr? Tell me why. Tell me the problem. Like, what was the problem you're facing? Not able to visualize anything. The three-dimensional memory is 0. Nowadays, people go to the theater to watch the 3D film. Why? Okay, I can only hope that you will understand one fine day. Tell me if you have some problem in the understanding part. What you're not able to understand? How the element is cut and what? I think I have cut this element in the past also. This is the element which I have cut. Let me show you in dark. Can you see the element? Probably not. You can't see anything.
Yes.
So if you can see, then can you answer it? Or only you can only see it. None of you are able to answer anything. What will happen? Everything should be spoon fed, huh? Always remember, if you are only good with spoon feeding, you're good with nothing. Okay. So what about the R3? Okay, this answer is pretty much simple. So all such element, if you go from I2, so every cut which you will make will be parallel to, one after the other. So they are in series combination. So the net will be dr2, you can do it directly. So the answer will be L in B by A. by dt. Now, if you can't answer R3, then probably you haven't answered anything so far. So tell me what is R3. So while moving in the direction of I3, tell me, is the cross-section area changing? Yes or no?
It is like the area of the sector we take.
Yeah,
Yeah. So is it constant, or I'm asking
Uh,
the
it
area is
will
changing
be
or not?
constant.
constant.
Correct. So solve it. That's correct answer.
Hello.
Yes, tell me.
Rho T. Hello.
Rho
Rho T upon
hmm,
half B square minus theta.
very good. So that is the right answer. So we have Arun Atwati. So you can apply this formula to solve any other question.
Yes, sir. I also got.
Very good. See, if you haven't studied, understood elementary so far, then you haven't learned anything from me actually. Probably something is happening in all of your brain. Okay? The way you want to learn and the way I'm trying to teach, I think we are not on the same page. I'm saying do the derivation, understand the elementary. You want the formula, you want something else. So there is a conflict actually. So now we can go to the. So let me explain the Ohm's law once again. We have derived the formula, but we will try to understand the Ohm's law and we will come back to some numericals. So what is Ohm's law? What is this law all about? It says that according to this law, the rise or fall of potential across any resistor is directly proportional to current flowing through it, keeping the standard, keeping the temperature and pressure, let's say, constant. So Ohm's law is highly misunderstood law. It is not a law about proportional relationship. So first of all, every resistor, you should know that there is a circuit representation. So circuit representation of a resistor so if you have a resistor, any you can do a zigzag and that is called resistor. So now no matter what, if a resistor is a part of circuit and if there's a current which is flowing through it, then we should know that current only flows from high potential to low potential. So the moment you know the direction of current, you can always guess which one, which end is at high potential and which end is at low potential. So you can always say that, okay, the left end is at high, the right is low, because you have taken the current direction towards right. But if you take the current direction towards left, then the left and the right becomes high potential, and the left end becomes low potential. So it is entirely the assumption. Now what Ohm is saying, that the potential rise or drop, which we call voltage. So if I say this is at voltage V1, sorry, potential V1, this is at potential V2. So voltage is basically the difference. So what Ohm said, that along the flow, the potential will drop and against it will rise. You can always take the analogy. If there is a waterfall and if you try to go along the flow, you will come down. But if you go against the fall, you will rise. Similarly, if there is a current and if you try to move or walk along the flow, you will go towards the lower potential and vice versa. Okay. So the V is the potential rise or fall. You can just take the value is proportional to current flowing through it, and therefore you write V equals to some constant. This constant we call I. Now the R was the consequence of Ohm's law. Then when he tried to investigate what is R, so what he did was he applied the potential difference, that is the voltage, and he got some current. So when he applied potential difference of V1 value, he got the current I1, then V2, I2, then V3, I3, and so on. So what was interesting here, that the ratio which he got in each experiment, this ratio was a constant quantity. And because this is a constant, so it must be representing some characteristic of the media or the resistor. So this characteristic was called resistance. Okay, so this is called resistance. So resistance is the characteristic of a conductor by virtue of which it will always oppose the flow of charge, that is current. So current definition I wrote in the last class, yes or no? The definition of resistance,
Yes,
Yes, sir.
that's done. No? I don't need to write again.
Yeah, yeah.
it was done.
So what is the resistance? It is the opposition offered by the conductor for the flow of charge. That is correct. Okay, let me rewrite. Even though quickly I'll mention. So what is resistance? It is the opposition offered by conductor for the flow of charge. That is correct. Okay. So anyway, a pretty simple definition. So the ratio of V and I is a constant quantity. So what you need to remember, that R does not depend on velocity, potential difference and current. It is the vice versa. It is the V which depend V and I which depends on R. So for a given V, the I is predetermined. Okay, because R will say the answer. Okay? So the whole idea is, because R is a characteristic, so that can be always calculated. The second thing which we need to know, that do we define R for the medium or do we define R for the terminal made in a medium? Tell me. Is resistance defined for the entire medium or is it defined for the terminal?
Like the terminal?
So just like current is defined for cross section, the resistance is defined for two terminal. So if I draw some hypothetical shape object, any shape, you just do whatever you want, and then you take a nail, let's say you put two nail into this medium, and then what you do is you connect some potential difference. So what happens, this voltage source will create a charge polarity here, and then this will create the lines of force. Technically this actually happens. And this lines of force will only start from the plus and will end to the minus. Lines of force will be everywhere, but the lines of force will be mostly dense between the terminals. And as a result of the field which we develop, the free charge, which is the electron, will start accelerating or simply drifting, and that drifting will occur as per the field direction. Okay. And as they will try to drift between the terminal, you can clearly see they have to go through the medium, and therefore the resistance will develop. So by bringing the terminal closer, what will happen? If I bring the terminal very close, then what will happen? The travel distance will decrease, yes or no? Because most of the lines of
Yes.
force will be
Yeah.
densely packed between. So as you decrease the travel distance, what do you think? The resistance will? Resistance will also decrease, right?
Decrease. Yeah.
Yeah. So farther the terminal, more the
Resistance.
resistance. And you can think always the nearer the terminal, lesser the resistance, because you have to go through a small piece of medium. So it is the lines of force which eventually dictates the amount of resistance. Okay. So if you connect any battery, and if you have if you can measure the current, then the resistance of this medium for the given terminal, see, resistance of a medium cannot be defined. So we can define resistance of 1 and 2 for a given terminal is the potential upon current.
Yes.
So this method we employ to find the resistance of any medium across any given terminal. What we do is we apply the potential difference. We apply the potential difference and we check for the current through the battery. We check the current here, not in the circuit, not in the medium. We check the current here. So we apply some device called ammeter, which you will come to know what is this. And once you design it, the medium's resistance can be determined. Understood? And if you take a finite shape also, then the thing will be really easy. If we have a terminal and if there is an infiniteness of the medium, then it will create the field lines as per the theory of electrostatics. Okay. So field lines will be as per the theory of electrostatics. So whatever you have learned in electrostatics, the same idea you can apply. I hope this is clear.
Yes.
Okay. So this formula is really powerful, and we can find the resistance of some randomly designed medium, and We'll see how much resistance it will offer. So let's solve some question. Okay. So the first question is, let me write down the question. Good question. So yeah. So this is basically question number 3.157. In effect, if you look from the question number 3.154 to 3.15789 160. So all are based on very basic concept of the formula. Okay,
Sir,
which we know.
which book?
Irodov.
Oh,
So we're going to solve few of them. Rest you can solve as a homework. So let me solve one question. Start with 3.157. 3.157. So that's pretty much easy. Okay. Question is, two metal balls of the same radius A are located in a homogeneous poorly conducting media with resistivity rho. Find the resistance of the medium between balls provided that the separation between them is much greater than the radius of the ball. So this is the question. So you can draw two metallic balls. You can assume this to be very small, and it is kept in some poorly connecting medium. Okay, I don't have a space, so but the medium is not confined. It's everywhere. So the question is clear to all of you. Let's say the radius is given in the question. And the rho is the resistivity of the medium. So what we do is, if you connect a battery across the sphere A and B, so battery will give some positive charge to one of them So I'm not drawing the battery because you know that charge on one of the sphere will be positive and the charge on the other sphere will be negative, right?
Yes.
And if I draw a cross section area across it, so the electric field lines that will cross this boundary will cross the entire medium and reach the other end, isn't it? You can draw something like this. Okay, no need to draw everything. So how we approach the question? So you can assume some charge Q here. And some charge here minus.
Sir,
Yeah,
sir, we will take the potential of the balls into
Yeah,
consideration,
correct,
like the
correct.
self energy.
No, only potential. What you
How?
need? See, what you need is two things. You need V and you need I.
Yes.
So how to find V? You find the potential of the left sphere, right sphere, take the difference. Because V represents potential difference, right?
Yes. Ha.
We know the formula how to write potential difference.
KQ by.
Yeah. So the delta V is how much? Tell me. For the left sphere, the potential is KQ by A.
Yes.
Minus the right sphere is minus KQ by A.
Minus KQ by.
So the delta V turns out to be Q by 2 pi epsilon naught A, right?
Yes.
And if there is a current, which we don't know, if there is a current flowing through this I, then I will be how much? And if you remember the formula, I have derived the I in a very nice way in terms of flux. So I was, pardon?
Sigma into flux. Okay.
Yeah,
Okay.
yeah. So I was sigma into phi. And therefore we can write I equals to flux by resistivity, right?
Yeah.
Yes.
So we know delta V, we know I. So the resistance is what? I have written in a very bad way. But these two formula is sufficient to get the third. So R equals to of the medium is how much? Because the current will see, current is a constant quantity. So the current through the nearest surface area is the same throughout the medium, isn't it? So the net current we can always find like this. So R equals to delta V by I. And the answer is how much? And flux we know the Q by epsilon naught itself is flux through the surface.
Yes. So it will get cancelled.
It will be cancelled. I missed A somewhere. Yeah, A. So it's a simple answer you can see. So this
Yes.
medium will offer you how much? The resistance offered with the medium is rho by basically the flux here is. So
Sir,
there may,
sigma is conductivity, right?
yeah,
Yeah.
that's why I wrote inverse as resistivity.
Yes. Yes.
So there are many ways you can. This is the way to solve the question. Most of the question you can solve using the idea of capacitor. You know how to write potential. So it's basically all of these questions are electrostatics based question. You need to know how much you're supposed to use the electrostatics. Let's solve the question number 3.163. All are very simple questions. Like I'll solve few of them. The process remains same.
Sir, which question?
Let me tell you. So next we are going to solve is 3.163.
6.
See, every type of question we have done in the past, but you just need to explore on your own. So, do I need to write the question, or you can read from?
Sir, can you send the question
Okay, just
now?
I'll send in the group. Okay, so I've sent all questions. And you can expect this question in JEE-Mains also. These are not difficult. Much question. Huh? This is the entire Untitled chapter, current and electricity.
Sir,
Yeah.
sir, in this question, what I did that we need the current, right? So I used the formula sigma into the flux. Is that correct? And
Okay.
for the flux is the charge enclosed upon epsilon naught. So I found the charge by the capacitance.
Okay. So you can check the answer. I'm sending the answer. You can check just a minute. So here the sigma is variable, no?
Yes, that only I had doubt.
When sigma is variable, it means at every layer there is a change of charge. Okay.
Oh, yes.
So you have to find
Okay.
sigma as a function of x first. The first step is find the sigma as a
Okay.
function of x. Okay. Okay. No need to solve everything, but I'll tell you how many questions you have to solve. So 80-90% is doable. 10%, no, 1 or 2 questions are
Sir,
beyond.
sigma varies by distance.
Yeah, so you have to express sigma as a function of distance, right?
Yeah.
And then
Yes.
apply the formula for resistance at dr equals to rho dl by a something. And then integrate, no? Because sigma is variable, so you cannot write the formula. Whenever something in the actual formula varies, whether it's a resistivity or length or area of cross section, the elementary must be applied. So you have to think of elementary, how you're going to cut the elementary. And once you cut the elementary, you should know that what to be done next, whether we need to do the integration, differentiation, or whatever, and then get the answer. See, this process is almost similar in every chapter. So in a sound chapter, we have a similar question. In thermodynamics, we have a similar question. But the method of writing, I hope that you all can plot the graph at least. So you all can plot the graph. And it's a linear equation, right? Equation of line. So once it is a line equation, I hope you all can also write the equation of a line. So finally, so we got our 3 Nobel laureate today. Ellen Aspect, John Closer, and Anton Zeilinger, something like this, for the quantum entanglement. So Ellen, John Closer, then Anton Okay. So inherently, we all are some way connected with the quantum entanglement. That's why when something happens to your near and dear ones, you feel something like a deja vu. So you are connected. You're not isolated. So how many of you have heard about this quantum entanglement? Anyone?
Yes.
Okay, solve this question. So question is clear to all of you. How to attempt? Is the idea clear? Like how you are going to solve it? Yes or no? Tell me. The gap between the plates of a parallel plate capacitor is filled with inhomogeneous, poorly conducting medium whose conductivity varies linearly in the direction perpendicular to the plates from this to this, and that's pretty simple. So the area of the plate is S, the gap is D sigma 1 sigma 2. Don't use the value, just use the. So you know how to do a parallel plate capacitor. And it is filled with a very non-homogeneous medium. And definitely it's non-homogeneous because the sigma is variable. And it is varying linearly in this direction. So if I plot a graph of sigma versus x, so if you don't know all this basic thing that how to convert a statement into mathematical formula, then please learn it as fast as possible. And if you haven't seen, then you can go and watch my basic mathematical tools videos. You will learn how to write all this. Technically, you are not supposed to watch because you know what is straight line. The problem is you don't know how to use it. You only know as a fact, as a matter of fact, okay, this is something for a straight line. And this is D. So you can clearly see the slope is how much? Intercept is sigma 1. So sigma you can write as slope, which is sigma 2 minus sigma 1 upon D. Y equals to mx plus c. So you're not supposed to read this again. I don't know why you guys are not able to convert math into physics. And you study math so discretely that we don't understand math as well. You understand only formula. I'm supposed to use this because this is given. It is being said to you, use this. How the country will develop. I always dream of having some Nobel laureate from here itself. That's not possible. Entire learning process is screwed actually. All are looking for marks, numbers, not for learning. Until we do not start, study science for the learning purpose to discover something, we as a country is, we're not going to develop at all. We'll remain at least 100 years back. What we will become good with is services. We'll give services to the world without any breakthrough, only services, like a cheap labor. That's it. Anyway, so once we have sigma, and we know it's varying with along x-axis. So because sigma is varying over x, so if you move x and cut a dx, then across this dx, we can say something that the sigma will not change, because sigma, this is so small that sigma at this location up to this location is almost same. That is equal to sigma x. The sigma at x is something which is constant, and therefore you can add the dr, the resistance equals to, what is asking, the resistance? Find the current flowing through this.
Current.
Correct.
Yeah, potential. So anyway, you need to find resistance only, na?
V by R.
B by R. So the dr equals to 1 by
1 by sigma dx
d
by s.
x by s, because the area is constant. So dr turns out to be dx by sigma is sigma 2 sigma 1 d x sigma 1 whole into s, and this is pretty much integrable. X will go from 0 to d itself.
D.
And I know the integration will be also a difficult task, so let me do this also. Tell me what you guys are good with, like good at. You struggle every day with maths, eh? And this is not mathematics basically, this is common sense, like a basic calculation. I do not expect that this is supposed to be taught at all. Something which everyone should know, inherent. And we have to divide by the coefficient, which is sigma 2 minus sigma 1 by
Sigma.
d. It is d sigma 2 minus sigma 1 s into ln. And if you put d, you will get sigma 2 by sigma 1, right?
Yeah.
Such a nice answer. So current is how much? The V by R. And R is d ln.
S.
So final answer is sigma 1 minus sigma 2. Sigma 2 minus sigma 1. So it is just a process. It's I would rate this question at a level of 1 to 10, level 2 question. That's it. Because it's just a mathematics. If you know basic straight line, how to write elementary and so on, this is like piece of cake. Why you're not able to solve it? Only you can explain. I mean, what exactly you need to solve this question? I can tell you the problem. None of you are able to understand the whole purpose of elementary in physics, which I have been telling for last years, 1 year, 2 years. People are not ready with their open mind to understand the elementary. They listen in the class, they again forget. And no one is trying to realize it. Why are we learning elementary? What is the purpose of elementary? What exactly is elementary? What we achieve with elementary? You achieve with you apply the formula which is not applicable in general becomes applicable when you take elementary. That is whole idea. The day you will get it, you will appreciate the purpose of elementary, the meaning of elementary. Till then, I can only expect one fine day God will give you some sense to understand elementary. Hopefully, one fine day you will understand. So all questions are trivial questions. I mean, just take any question. Okay. Question number 3.155. Again, it's a trivial question. How? Let me show you. You can read the question meanwhile. So this is A and B. And this is the medium which is filled. So the medium is, I think, yeah, the rest of it is good. So what is the resistance of this medium? Beginning from here, ending till here. So when you know the beginning and the end, you can think as a terminal. Think as a terminal as think as a charged bodies, one plus, other minus. Think of the lines of force, think of the field lines, and the field lines will be the current flow direction as well. Think of the current density and so on. And you can solve by 1,000 methods. So the best is,
Sir,
yeah,
we can think this problem like we did in capacitance. Dielectric is filled between the shells,
yes,
like
yes,
that.
yes, 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 exactly that. You can use the formula of R equals to rho into L by A, apply it for the thin shell, integrate, that's it. That's the easiest method. So the easiest method is write dr between, if you start from here till here, take a elementary shell, write the dr for the shell, then integrate because it's all are in series. Just you need to add. So write the elementary, take the elementary first of all. In case of spherical object, you know how to take elementary. So take elementary, write the equation, and do the integration. And if possible, do realize this. As a beginner, anyone who starts studying, I mean, competition for like JEE and all, if you have cousins anywhere in the world, tell them do not spend time in learning physics or chemistry. Only spend time in learning maths for first 6 months, and especially trigo and calculus.
Sir,
If
I
you're not
got
doing
the
all these
answer.
things, you're making a big mistake. Yes, tell me.
Sir, I also got.
Tell me the answer.
Rho B minus A upon 4 pi AB.
Sir, I got rho
Hmm.
by 4 pi A. But B tends to infinity.
That is second case. That is second case. Before that,
No, but the initially
yeah,
this
Yeah,
should
initially,
be the
then
answer.
same. Yeah,
initially is how
then
much? Initially is how much?
Initial is what I said.
Yeah.
The
yeah,
answer.
same. Same
Yeah.
1 by A minus 1 by B.
Correct. Correct.
Yes.
Very good. So I think now you are getting the right answer.
I read the question and told.
Yeah, yeah. That is the second part, but that is good. That's the second part. See, JEE preparation, which I have observed over the years, is very trivial. It is just like no one is ready to do the hard work in the beginning, and somehow they have the expectation that they will master the physics or anything later on in 12th class. Okay, anyway, that is the only flaw. And because only handful of the students in the India is or are okay getting through this method, they qualify with ease. See, you ask anyone who has qualified, they have worked hard. I mean, I would say out of uh, anyone who qualified, let's say 14,000 is the qualifying rank. Out of 14,000, those who are in top 3,000, they generally don't study in that way. I mean, their study method is similar to what I'm saying. No hard work, only learn the derivation, learn the derivation, learn the derivation, and through derivation, get everything, whether it's maths, chemistry, or physics. You can always do this. And this is not something which is taught actually. It's like you realize, you just one fine day you realize. I was not told that to take elementary and do this. I saw someone taking elementary and realized, okay, what is the purpose? It just struck me and it was in my mind forever. I don't know that ever I put any effort to understand this. It's natural to me. The first day I studied as a student, I'm not saying as a teacher, I'm saying as a student, the first day I heard the definition, I was knowing, okay, what to be done next. It is so trivial. So the derivations are very trivial. You just need to do something, a routine job. And the good thing is, once you know the derivation, the elementary, there is similar repetition throughout physics. So you go to any chapter, you see a similar thing. Okay. So the entire preparation becomes trivial. If you don't do that part, it is difficult. It is challenging, and you will search for something other. You will search for the answer. The thing is, answer is hidden there only. You're not supposed to search for answer. It is there. Just one fine day while deriving it, try to understand what you are doing. One fine day, just it's the only moment of eureka moment will come in your life, and it's done. That's why I say physics is either trivial or it is impossible. There is nothing like partial physics. You exactly if you know the physics or you don't know the physics, and there's nothing in between. In between, of course, there is a practice which enhances the speed. That's it. Okay, so now you can add dr equals to rho L. What is L here? No, what is L? How the current will flow? In the radial direction, right?
Yeah.
So what is L here?
dr.
D.
dr only.
What is the area here?
4 pi r.
4 pi r square.
So what's the big deal about this question? I'm just starting. This is the answer, right?
Yes.
And then B tends to infinity, then R tends to rho by 4 pi,
Rho by 4 pi.
Yeah.
which is exactly half of the double sphere problem. If you do you realize the problem, the first problem? It is rho by 2 pi because we have two sphere, right?
Yes.
Yeah.
It's a like a this is the double this answer.
Oh.
The answer is just double. This is half actually. So if you bring two sphere, then so what will happen? The lines of force will diverge, but while
Double.
coming towards it will again converge. It will again, try to go through the medium with higher resistivity. So the answer becomes twice. You can think that way also. It's very natural. Okay. And you can do this even when I say the rho is variable. So let's say if you have given the same question, two concentric sphere, you can just play with the idea.
Only integration will change.
Yeah, only integration. See, just see the basic thing. Don't see the big thing. Okay, so if I fill this, just so try to understand the bigger picture. What you do having something very trivial calculation. Don't say this as physics. Physics is when I talk about the theory. When I am teaching theory, that is only physics. The rest is not physics. These are just trivial calculation. And just because you haven't practiced, you call it theory. So let's say if I say rho equals to rho naught r, something like this, it's a variable. So as you go from the inner surface to outer surface, the resistivity will vary. This is resistivity now. So in the other chapter, it becomes the mass density. In chapter of electrostatics, it becomes volume charge density. So everything is only context, but the mathematical calculation is same. It is trivial
Sir,
everywhere. Yes,
the answer is rho naught by 4 pi ln of b by a.
correct. Very good. So here the dr will be how much? Rho, which is rho naught r.
dr
L
dr
is
by
real.
4
4
pi r
pi
square.
r
L is
square.
4 pi r square. Very good. I'm just writing the answer. Oh, this is. So do you realize that all these questions are trivial questions?
Yes.
Yes.
So what you were trying to learn, you have to rectify that part. Do you learn the formula? Do you learn the derivation? Do you learn the context and the derivation? That is the most important part. I always reiterate every time that try to understand when your teacher is deriving something, under what condition, using what formula. See, in my mind, I have only one thing: R equals to rho into L by A, and that is more than enough to solve any question of radar. Imagine a simple formula: R equals to rho into L by A is more than enough. Do you learn in that way? Yes or no? That is the question you have to ask. And then when you interpret R equals to rho into L by A, how you interpret? That is the other question. Okay. You can find, see, every question you can solve by 2-3 methods. Now finding R is the most convenient way to get the answer, but I can just reproduce the same answer using the definition of electrostatics. Okay. So we know that no matter what, the current is a constant quantity, isn't it? I is always constant.
Yes.
Okay. So for every given situation, I can add current density. So for, let's say, for this case, let me demonstrate something. How we think. So we know I is a constant quantity. We don't know about other things, but I is a constant. So let me just do a bigger one. So if you draw any cross-sectional surface at a distance r at an in general location, even you don't know what is current, but you can always say that the current density in terms of current, right? So
Yeah.
you have no idea what is current, but let's say whatever is the value, that is going to be fixed. So current density at a distance r will be how much? Tell me.
I by 4 pi r square.
I by 4 pi r.
R
That's,
square.
that's
R
always
square.
true. I mean, even if you, whether
Yes.
you understand or not. And the moment you get this, you can just add the sigma into E formula. Okay. So I can add a sigma into E. So I will get the electric field in terms of the same answer, which is I by 4 pi r square into rho sigma, which I can write as rho I by 4 pi r square. Okay.
Yeah.
And then we know the potential difference formula from electrostatics, E dot dr
Yes.
with minus. I mean, I'll just take the value. So the delta V modulus will be how much? E dot dr means rho I by 4 pi and dr by r square, which is 1 by a minus 1 by b.
Yes.
And then I got the delta V in terms of I itself. You can see directly. And therefore, the delta V upon I itself is rho upon 4 pi 1 by a minus 1 by b. And by definition, this is called resistance, right?
But so the first method was the direct thing,
Yeah,
right?
of course.
One line.
I'm just showing you multiple ways. Say you can find
Yes.
the intermediate value also. Okay.
Yes.
So things can change, and therefore knowing the fundamental ways is always beneficial. And you also know, you need to know that okay, there are many ways. Every way will have some benefit. Let's say if they will give you J directly, then how to approach? If they give you something else directly, if sigma is also variable, okay, if you can do away with every calculation if you just know simple formula, current density, current relation, and so on. Now it is a spherical question. You can do it for cylindrical. You can do it for other case also. You can do it for frustum also. Every question can be solved. What you need to know is R equals to rho into L by A, and Ohm's law in the which form? Local form.
Look,
J equals to sigma E.
sigma.
That is more than enough. So all formula that you, if you want to express in terms of flux and something, you can get the answer there also. Okay.
Yes.
And don't worry, these questions are basically part of JEE mains question. The current chapter in mains is difficult than advanced. That's the history of
Oh.
current and electricity. So you can always expect a better question in JEE mains than in J advanced. Advanced is very
So
cheap and
easy questions are in
very easy.
advanced than we saw.
Yeah. So from current chapter, you can uh, assure 100% scoring without any loss, without any question. You can score 100% from this chapter. So that's why this chapter is something which you should put effort, and you can guarantee that you will solve. It is not like okay, 1 year you will be able to solve, other year you won't. It is so trivial that every year, every time you can with guarantee you can solve every question from current and electricity. Okay. So the second method which I explained, you can imagine that just by knowing the electrostatics, you can solve every question, isn't it? Only if you know the electrostatics. Okay. So I think we can move to the next concept actually. So we'll quickly finish the grouping of resistors. We have done this in capacitor, grouping of resistors. And we also know from your high school. So first, like 10, 12 question of, or 12, not 10, 15, 20 questions of Eroda is only based on this basic calculation. I mean, it's so trivial that if you have understood today's lecture, you should be able to finish most of them, if not all. Few questions are beyond the JEE calculation, but that you can omit. So grouping of resistors. The first is series grouping. So we have three resistors which we represent like this. Now these resistors can be cylindrical, spherical, linear, or capacitor based. But for you, it's just a circuit part, a circuit element. And this is a symbolic notation for resistors, nothing to do with the physical appearance of resistor. Okay. And then you connect across a voltage source. Okay. So now whatever current is flowing through this, the current will come here. And the same current, I mean, of course, current is always same. It's like a tube of, you can think as a water or any liquid. So water will circulate. So what is the role of battery or the cell? The role of cell is to regulate it. So we all know that cell is not able to create charge. It is only able to regulate charge, which means you create a potential difference and you make it like a motor, like a, you create a suction at one end and you push the water at the other end, and you keep on driving in the same fashion again and again. So there is a circulation of current throughout the loop. Okay. So some part of the loop is fairly connected, and the battery is the part which is like it will take the charge and put it on the other side. So the direction of flow of current is from high to low potential in the remaining part of circuit except the cell, because in the cell the same current goes from low to high potential. I hope you realize this fact. So it is like a mountain hill, you can think this as. So you take a sphere and you push it. So you push it up the hill and you release it. Again, it comes back on your own. Then again you bring it back. So this is the role of cell. So in a circuit, the cell role is to push the charge, or you can say, or charge only, from low to high potential. But the rest of the circuit, the charge will go from high to low potential. Okay. So there's a role is different. So within the cell, how the charge will move from low to high, and outside the cell,
High to
high to low. So that's very simple, which one should remember. The cell will take or move charge from low to high potential within itself, but will push from high to low outside it. So you can say in a rest part of circuit, the current will go from high to low, but within the cell it is going low to high, and that is why we need to do some work. Okay, so cell is the one responsible for this work. Otherwise, all charge will accumulate at this end and nothing will happen. So to make it a flow, you have to take it again here and then do it here, release, then take it here. So this constant work needs to be performed by someone. This constant work needs to be performed by someone. This is the someone. That's why the cell is called the driving force of circuit. Okay. So we call cell as the driving force of circuit. Understood? Is this clear, guys?
Yes.
yes.
So this is some basic stuff. We'll talk about the cell in detail after this topic when we are done with the citizen panel. Okay. And what we try to achieve? We try to achieve a equivalent resistor. I have discussed this before. Let me remind you again. So what is the meaning of equivalent resistance? See, resistance is the characteristic which always dictates the relationship between applied potential difference and the current. So when you say equivalent resistance, then this should always let the circuit draw same current as before. The three work together trying to derive. So what should remain same in equivalent circuit? the flow of current under the same potential difference. Understood?
Yes.
Or in other words, if I change the potential, it should change the current, but the ratio of V and I here and
Same.
V and I here must be same. So we keep the same potential and we expect the same current because we expect the same voltage. I mean, sorry, same ratio. So I is going to be same, and then from Ohm's law we know that potential will drop across the first resistor by some value. I hope you all know. 1, 2. So the potential drop or rise, you can add V1, V2, V3 as value. So if you go from left end to the right end, what is the net drop of potential? So minus V1 drop. Okay, drop, drop, drop. Now you're at the right end here. Come down, come down. Then if you try to go back, what will happen? You have to rise, right? Low to high, isn't it? So you will rise by potential V, and then you come back to the same point. So if you begin and start at the same point, the drop and rise must be 0. That is entirely called Kirchhoff's voltage law. But anyway, you can act by common sense. So the potential and the potential of each individual resistor we can relate like this. So one potential, the potential difference of the cell, is now divided across each resistor. So all will have some sharing actually. And you can add the formula. So V equals to IRS, V1 equals to IR1,
IR.
which is the Ohm's law actually. We are writing Ohm's law again and again.
Yes.
And we all know that this is why I'm driving it, I don't know, but anyway. So I should have skipped directly, but we don't have time. So for parallel grouping, quickly, for parallel grouping, so now the cell is at the bottom, you can see, and then whatever current will flow out of this cell, you can think that way. The same current will come here, and now we have a junction. This is called junction. We'll talk about this in detail, don't worry. So junction is a point at which, okay, I think we have discussed in
Yes.
capacitor. Yeah.
3 are meeting there. So
Yeah,
junction.
correct. So at junction, what will happen? The current which is coming will have the division of current. So we can say I2, I1, I3, and these all current will flow and again meet it here. They'll meet back, and so it will become I again. Now because they are in parallel, so what will remain same? Because they have same terminal, and potential is defined for each terminal. So we can say they will have same terminal potential difference. So the V is the constant quantity, so we can add V equals to I1 R1, same as I2 R2, same as I3 R3, and if you wish to replace by a single R equivalent. That's again trivial question. So we have to write the junction rule. What is junction rule? The current is at any junction. We know that I'll just write at junction. So at junction, the incoming current is I and the outgoing is I1.
Incoming will be equal to outgoing.
That's common. Yeah, very good. So now we can replace or substitute I equals to in terms of voltage because V is a similar quantity. So this is also I into RP.
V
You can write
by
I
R.
equals to V by RP. Correct. Is V by R1, V by R2. And therefore we know the answer is 1 by RP. In general, let's try quickly in general. For n identical resistor, if all resistors are identical, then it becomes n by R, so the
N.
RP becomes R by N. So in parallel grouping, what happens? The resistance will decrease in value, right? So by parallel grouping, you decrease the value. For series, you increase the value, right?
Increase.
So for two resistor, R is, and it will have the similar, method as I did in capacitor. The big upon is small plus 1.
Yes.
So this is trivial. Okay, what you can solve? Let me tell you the homework now. So your homework is quickly. Let me remind you.
Assignment.
Assignment is that is there, but so you will solve question number from Erodov 3. Okay. Oh my God, you have too much homework.
It's okay.
Finish from. Yeah, that's it. Yeah. In spite of the fact you are solving assignment, you have to solve some question from Erodov, because again, every question you won't find everywhere. So no book is sufficient. Like Erodov is not good for something. So your homework I'm giving you. Erodov homework 3.147. 3.148. 3.149. We have done the Q problem from capacitor. You have to solve it.
Yes.
3.1. What is 50? Yeah, that is 50. 151. This is infinite ladder problem. We have done this. We have done the grid problem, so that's the same here. We have done the 3.15, 1.54. We have done this question. So do it 155, 156. So we have done the 7, 8, 9. Okay, I think. Up to, okay, let's me to tell you, this is 1.147 up to 1.163. So how many total question? 3, 10,
16.
roughly 16, 17 questions. Okay.
Yes.
This many questions you just solve as much as fast possible. You can leave the question number 1.6, 3.162. You can leave that part. That's it. So this is your homework. Apart from the assignment you do on a regular basis, so every day solve at least 20 questions or 10 questions. It is, I mean, not difficult one. Okay, the difficult one you will get very soon after this 1 or 2 lecture. Okay, so let me end today's lecture here because someone will have to join other lecture also. Bye guys, take care. Plus do keep on solving, and do not forget electrostatics because that is the base of every chapter. So the entire 12th will have the only one base, electrostatic, and it seems like many formula you have forgotten already. So if possible, do revise before the next lecture. Okay. Yeah, you have to keep on revising electro. Otherwise, things will become difficult for you. Bye and take care.
Bye, sir. Thank you, sir.
Happy
Bye, sir.
Dasara to
Thank
all.
you.
Happy Dasara to everyone.
Happy Dashara, sir.
Happy Dashara, sir.
Thank you.